Okay, today we're going to be talking about volumes, trying to find out what the volume of a solid is. Okay, we're trying to find the volume. All right, first thing is to let's understand what this isometric dot design here is. So what I'm going to do is draw some lines. Okay, the first thing, make this line here. Let's just go right to here. And then this line right here. Okay. What this is the x and y axis. Okay. Normally we see it like this. Normally we see, remember, the x and y like this, being y and x. But in this case right here, this is what it's going to look like. All right. So that's the x and y. And we know that if we had an object, let's paint this right here in green. If we now have an object that looks like this, it goes from here to here to there, all right, and then back over here. Each one of these points right here we know is 1. So that would be a 1 by 1. Okay? So the area that we know of this right here is 1 square units. Whatever these units are here, but that's what this the area of this square here is 1 square unit. So let's go a little bit further, and let me find my eraser here, and let's get rid of some of this right here. Okay, and what we'll do now is make something a little bit larger. All right, go back. Let's back over here. Let's make something a little bit larger. Let's take this guy and go all the way over to here. Let's just take it all the way over to here, and then all the way over to here, and then all over to here. Now I think we can agree. We can agree now that the area of this rectangle, which is 3 by 2 units on each side, both the let's call this the length and this is the width, or we can find the area. Remember, we can find the area is going to be equal to the length times the width, or another way of doing that is the area of this rectangle is going to be equal to the base times the height. Let this be the height and this right here be the base, and which we know is going to be a 3 times 2, which is going to equal to 6. I think we can all agree on that. If we look at this right here, let's put a dotted line in here. If we look at this closely, we can see that there is in fact 6 little squares in there. 1, 2, go back over here. 1, 2, 3, 4, 5, 6. So there we go. So that is equal to 6 square units. All right. Now let's change gears now. Let me erase most of this right here, and then we'll go over to a volume and use this as a 3D. All right. 3D, and let's go back over here to this, get rid of that guy and that guy right there. That guy, that. Okay, now go back over here to my pen. Now let's take a look at this. Remember here is that here we go. Now we're going to take this all the way out. Let's take it all the way out to here, and this all the way out to, let's go to here. And we discussed before that this is y and this is x. Now in the third dimension, we're going to add a point right here. Let's put it down from here all the way up here. And this is the z-axis. All right. Now, if I draw my object, let's make a cube this time. A cube. We start here from the origin. We go over to there, over to here, over to here, and then over to here. Now we know this right here is that's a square, but as soon as I put height in it, then let's look at this. And what do we have here? We have this going up to here, this going to there, and this going to there. Now we have a cube. This one right here is, again, is 1 by 1, and this distance right here was 1. So this one now here has, to find the volume, essentially what we're doing is multiplying the base times the height times the width. Okay? Here, let's say this is the base, this is the width, and this is the height. So that's going to equal to 1 units cubed, since we have 3 dimensions there. Now let's draw something that's going to be a little bit larger, and using the same theme that we have here, and let's use a purple. All right. Now I'm going to make this guy a lot larger, and we're going to then try to find the volume of this fellow. Oh, wait a minute, where'd it go? Go back over here. There. Okay. This should work. Here we go. All right. And I'm going to bring him all the way over to here. So this one right here, we know from here we got 1, 2, 3, 4, 5, and it's 1, 2, and let's make it 1, 2, 3 here. All right. So, all right. Then we take this, bring this all the way over to there. Oh, all the way over. There. Then we go over to here. Bring that there. Bring this one here. And then this one here. All right. Now we want to find the volume of this. This right here, as you can see, well, you can't see. Let's put some dotted lines in there so we can see what some of the dimensions are. So we bring this all the way over to here, and then all the way over to there, okay? And then this guy in the back. As you can see right here, okay, this right here is a prism, all right, because it's the way it's shaped. And let's call the base as a rectangular right prism. Now, how do we find the volume of this? Well, if we follow this same procedure that we just proved over here, let's try that and see if that in fact works. So we figured that this right here is 2 by 1, 2, 3 by 1, 2, 3, 4, 5. All right. So if we tend then at the volume is going to equal to the base. Let's call this right here the we can call that the length, width, and height. So we'll make that 2 times 3 times 5, and that's got to equal to what? 30, right? 15, 30. Okay, it's going to equal 30 units cubed. Now, are there 30 units cubed in here? Let's count them out. And let's try let's use a bunch of dotted lines here. That's the way we're going to be able to find this out. Let's find out where all these guys are. Find out all of these little cubes that are supposedly in here, and let's just make sure that there are really 30 cubes in there, so that we'll know for sure that this formula is really accurate. Okay, let's bring this guy over here. Am I missing some? Yeah, here we go. We got to get these guys in, right? Down here on the bottom. And then here we got to go. We got to go from all the way over to there, all the way over to there, all the way over to there. And hopefully you start seeing that we got some cubes in there that we can add up and find out if they're all there. Do I have them all? No, not all of them. I don't have them all in there yet. Let's see, I think, well, do I have most of them now? I think I got most of them there. So let's do some counting. We got this one right here is shaped here as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so 10 is going to be 11, 12, 13, 14, 15, and then we got 16, 17, 18, 19, there's my little line over there, and 20. That's 19. So we're missing 10 more, and guess what? These fellows are back here on the back side right here. So we've essentially, let's color this in with let's put green. So we've essentially colored all of these here, these in, which, so all of that is in there, and what we're left with is what? Is we're left with this group right here in the back, which is essentially, let's just bring this guy right here, which goes down, how high is this? 5? There. And that's by 1, correct? By 3. And by 3. Okay. By 1. No, I'm sorry, that's not by 3, that is by 2. Let's get rid of that one right there. Okay, this is by 2. As you can see right here, this is 5 high, 2 there. So let's draw this in, and then we'll have it. And I think you can see that this right here does really provide our remaining 10 units, which we figured out here. This one right here was 20. We left up with 20. And I think we can agree now that we've got, do I have them all right here? Yes, that we should have our remaining 10 of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we now have proven this, that actually this formula for a rectangular prism is going to be the length times the width times the height, as we found out over here in this case right here. So that's enough for this right here. So that's how we found our volume, and we'll see more when I go into a cylinder. Thank you. Have a good day.